Okay, in this video, I'd like to walk through several of the problems from the Test 4-5 practice that you'll find on Math Excel. Now, when I was in college using Math Excel for homework, I got in the habit of always printing out my Math Excel assignments, doing the work on paper, and then entering the results into the computer. That way, I got a little bit more practice and confidence in doing the work on my own. And then also, I'd be able to very quickly see which problems I was having trouble with because rather than punching in my results every question, I would punch them all in at one time. Those that I got correct, I just moved on, and those that were marked wrong, I would either circle or indicate on my printout and come back to them later. Now, I've done the same thing here, but in using my teacher's account, I've got the solutions that are shown right here. Now, you don't have access to that, of course, but this will help us with or at least help me with the conversation in the work for the assignment today. All right, so the test is kind of broken up into two parts where we have trig identities and establishing identities during the first half, and then the second half are trig equations, using identities as needed to solve trig equations. And sometimes identities aren't needed at all, as you've seen in last week's work. So anyway, we've got this expression here. Now I'm going to cover up the answer for just a moment. And we would like to simplify this equation, tangent squared minus secant squared of theta. Now at first glance, that doesn't look too bad. It's not all that messy. But if we focus on the identities that we had copied a couple weeks ago now, we might be able to simplify this just a little bit more. And so I'm going to focus on the Pythagorean group. Again, I'm doing this because I saw a tangent squared and a secant squared, and I'm thinking to myself, is there an identity that helps us to simplify or utilize tangent squared or secant squared? And certainly we have them right here. So on this particular assignment, if I see that tangent squared minus secant squared is equal to something unknown, I'm going to take a moment and I'm just going to rewrite the secant squared as tangent, or as its equivalent form with regards to tangent. So I'm going to jump out over here and I'm going to rewrite this as tangent squared minus, and then again, we're saying that secant squared, if you don't have it memorized, go back and look at your charts. Whoops. Keep selecting the wrong page here. There we go. Secant squared is the same as tangent squared plus 1. So the secant squared on our work today is going to be changed to tangent squared plus 1. Now if I clear the parentheses, I'll have tangent squared minus tangent squared minus 1, because this subtraction sign does distribute to both components. Now we can clearly see that tangent squared minus tangent squared is going to cancel because that equals 0. And what we're left with is simply -1, which is the solution that they were suggesting here. And I would again argue that this is a bit more simplified than this that we started with. In this example here, I see that cosine is being evaluated at a negative angle measure. So I'm going to switch to my identities here, and well, we've got a whole group of even odd identities that are going to help us. And even though the original problem says cosine of negative theta, I'm going to immediately change that to plain old cosine theta because I know those two are equal according to the even odd identities. So knowing that, jump out here. Cosine of negative theta is the same as cosine theta, and cosine theta minus cosine theta, of course, is 0. And as I punch that into Math Excel, we would be given credit for that particular question too. Number 3, tangent cosecant. And the instructions here are asking us to multiply these two. We're rewriting the result of tangent times cosecant, but they're also asking us to do this in terms of sine and cosine. So on paper, in a real-world situation, I might come up with a different answer than what the answer key here is suggesting, but we do have to keep in mind that the instructions are very clear on Math Excel, and they want our result in terms of sine and cosine. So in terms of sine and cosine, again, I'm using these trig rules, these trig identities from before. Tangent is the same as sine over cosine, and cosecant is the same as 1 over sine. So with those two identities, I can now rewrite this expression, and it'll look something like this. Tangent turns into sine theta over cosine theta. Cosecant turns into 1 over sine theta. And as I multiply those two together, sine theta and sine theta will cancel, and we're left with 1 over cosine theta. Now here's where we would stop here, because again the instructions said to rewrite in terms of sine and cosine, and that's a good result. But me personally, I'm not a big fan of 1 over cosine theta when we can simply write secant theta instead. Now MathXL probably won't give you credit for this because it doesn't follow the instructions that are given. Even though that is equivalent, you still won't get credit because you didn't follow the instructions. And I know students sometimes have trouble with that because they know they've done the work correctly, but MathXL is not accepting it. Well, most of the time when that happens, if you do the work correctly and MathXL won't accept it, chances are you didn't follow the instructions and report your answer in the correct format. Okay, in this next problem, well, the difficulty steps up a little bit more here because we're being told to multiply and then simplify the expression that we've got here. At first glance, you may think that this looks like a trig identity, and there may be one out there that helps us with this, but in the trig identities that we've used, we've not come across this. It kind of looks like maybe a sum or a difference rule for tangent or something like that, but that's not the case here. So since the instructions said to multiply, I'm going to start with this pair of multiplications in the numerator of this fraction. We've got a binomial times another binomial. And so we can FOIL this together. So I'm not messing with the 1 minus at the start here. So we've got 1 minus. Now my first product is cosine squared. And I better use a grouping symbol here just to be safe. Cosine squared. And then the outside product is cosine times sine. So I'll write this as cosine theta times sine theta. And on the inside, we get the same thing, sine times cosine. So I'll make sure to write that in the same order. That'll help me recognize that these two are like terms that need to be combined. Then negative sine times negative sine is positive sine squared theta. And all of that is written over top of sine times cosine. So after looking at that denominator a little bit more closely, maybe it would be appropriate to switch the order of these two so that they match the order in the denominator. Well, in the numerator, I need to point something out here. Cosine squared plus sine squared, that jumps out at me because I've seen this before, this type of work before, and hopefully you're starting to see this as well. Sine squared plus cosine squared is really the same as the number 1. So this is our Pythagorean identity, our primary Pythagorean identity. So anytime that we see a sine squared plus cosine squared, let's go ahead and rewrite that as the number 1. And so I'll do that now. 1 minus. Now these two combine to make the number 1, so I'll jot that next. And I've got two of the same terms here, so minus cosine sine, minus cosine sine. I'm going to go ahead and reorder those this time as well, so I'll just write this as minus 2 sine cosine. And again, I'm reordering those because the denominator has a sine theta times cosine theta in it as well. All right, so I think I'll go ahead and drop the parentheses now, and I'll distribute this subtraction sign into the grouping. So we've got 1 minus 1 plus 2 sine cosine, all divided by sine cosine. And the 1 minus 1, of course, is going to cancel out, and we're left with 2 sine theta cosine theta, 2 sine theta cosine theta over 1 sine theta cosine theta. The number wasn't written here, but it's implied. And the reason why I'm going to really emphasize that now is because, well, with a series of multiplications across the denominator and across the numerator, this will allow us to cancel terms all the way through. Remember, we're canceling terms like this because our elements are separated by multiplication signs. We couldn't do that all the way through back here because we had this grouping that was separated by an addition or subtraction. So that's why I didn't cancel the sine and cosine earlier. Well, sine cosines are gone. We're left with the fraction 2 over 1, which of course simplifies to 2. And if I check my answer with what's provided here, that's the solution that they suggest as well. So I'm going to go ahead and stop the video here. That was a little over 10 minutes. We got through 4 problems. In the next video, I'll try to pick up the pace a little bit and give you something a little bit more concrete to compare your work against. Thanks for watching.